Hi students, in this video we're going to talk about a trick for calculating the sine and cosine of some different angles from what we already know. So remember that, let's say I have an angle theta. Let me get a different color here. So here's my angle theta. And I look at the point on the unit circle that intersects this ray. And remember that the coordinates of this point tell me the cosine of theta and the sine of theta. Now, let's say that I take this theta and I reflect it into the second quadrant. So this piece is like my old theta, but I'm really looking at this angle. The one that starts here goes to there. So it's just the reflection into the second quadrant. Now I'm calling this other angle theta tilde. That's theta tilde, if you're interested. And what I want to know is cosine of theta tilde and sine of theta tilde. So basically I just need to know the coordinates of this point. But this is easy to do because it's just the reflection into this ray into quadrant 2. So if you think about it, since I've reflected, this distance is the same as this one. So the x coordinate should just be negative the old x coordinate. And the y coordinate's actually the same because I just reflected over. So the y coordinate's still 0.977. So that tells me that cosine of this theta tilde is negative 0.21 and sine is 0.977. Now we could keep on going. Let's say I reflected this into the third quadrant. So now this is the old theta. Well, my picture's not very good. If it were very symmetric, then we'd be able to see that the new coordinates would just have each of these negated. So let's put this into some rules. Okay, so let theta be in the first quadrant. So here's our angle theta. And suppose that cosine of theta equals x and sine of theta equals y. Now let's consider theta 2, which is the reflection of theta into quadrant 2. So I reflect theta into quadrant 2 means I'm looking now at this angle, theta 2. So in quadrant 2, the x coordinate becomes negative of what it was before, but the y coordinate stays the same. So cosine of theta 2 will be now negative x. Sine of theta 2 will stay the same because the y coordinate stays the same. It's still y. And another thing to notice is if I wanted to express this angle theta 2, it's just almost theta. It's almost 2 pi, but it's short of 2 pi by, or it's almost pi, but it's short of pi by theta. Because if it went all the way around, that would be pi, but it's theta back from that. So theta 2 is pi minus theta. That means we're in quadrant 2. Now to bump ourselves into quadrant 3, what would we have to do? Well, we would go another theta beyond pi. That puts us into quadrant 3. So let's call this new angle, the one that starts here and goes all the way into quadrant 3, let's call that theta 3, and we can express it as pi plus theta, because I've gone pi and then I've gone theta more. Now my x coordinate is negative and my y coordinate is negative, which means that the cosine of this theta 3 is negative of the cosine of theta, and the sine is negative the sine. Now if we go all the way into quadrant 4, so we'll do this one more time, that means I've reflected this way. So this little piece is theta. So by going all the way to here, I've gone almost 2 pi, but I'm short of it by theta. So theta 4 we could express as 2 pi minus theta. And you'll notice that the x-coordinate is positive, but the y-coordinate is negative. And since it's a reflection, the distance along each axis is the same, so only the sign changes. So cosine of theta 4 is still x, because cosine, in quadrant 4, my x-coordinate's positive, but sine is now negative. So what this allows me to do is to calculate the sine and cosine of 4 different angles if I know it for just one. So let's see some examples of this. Firstly, if I want to know the sine of 5 pi over 4, then let's draw a picture. My reference angle is the one that's in quadrant 1. And so that's pi over 4. So here's my reference angle. I know that cosine of pi over 4 equals root 2 over 2. And sine of pi over 4 also equals root 2 over 2. But I'm interested in 5 pi over 4. So which quadrant is that in? Well, here's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. So it's in quadrant 3. So all I have to do is take these and notice that now both my x-coordinate and my y-coordinate are negative. So cosine of 5 pi over 4 is negative root 2 over 2. Sine of 5 pi over 4 is positive root 2 over 2. So take that in for a moment. And we'll go to the next example, cosine of 7 pi over 6. In this example, my reference angle is pi over 6. So pi over 6 is in quadrant 1. We know that cosine of pi over 6 equals root 3 over 2. But I'm interested in the cosine of 7 pi over 6. So I need to figure out what quadrant that's in. And again, that one's going to be in quadrant 3 because 7 pi over 6 is pi plus pi over 6. So I go pi, and then I go pi over 6 more. And in quadrant 3, cosine is negative. So my final answer is negative root 3 over 2. Because I take cosine of pi over 6 and I negate it because I'm in quadrant 3. Okay, so now I want to do tangent of 5 pi over 3. What's my reference? My reference angle is pi over 3. And what do we know? Well, we know that tan of pi over 3 is square root of 3. So now I go again and see which quadrant 5 pi over 3 is, so I know if I keep it as root 3 or if I change the sign. So 5 pi over 3 is pi plus pi over 3, which again puts us into quadrant 3. And in quadrant 3, tangent is actually positive, so tan of 5 pi over 3 is just square root of 3 again. I don't have to change the sign in that case. Let's do one final example. Sine of 7 pi over 4. The reference angle is pi over 4. And we know that sine of pi over 4 equals root 2 over 2. So I go and I look where 7 pi over 4 is. Well, 7 pi over 4 is 2 pi minus pi over 4. So 7 pi over 4 is in the fourth quadrant. In the fourth quadrant, sign is negative because my y values are negative. So sine of 7 pi over 4 is root 2 over 2, but I have to put a minus sign in front. So this is how we use reference angles, and they're extremely useful. You'll see this come up a lot when we're trying to do inverse trig functions in section, I think it's 4.7. So let me know if you have any questions at all, and good luck with the web work. See you soon.